All right, so we've been working a lot recently with acids and bases, talking about their calculations and different characteristics. So now we're going to take a look today at how to name those acids and bases. Some general rules as we are looking at naming. For most of our strong bases, those are all going to be named following just the basic general rules for naming ionic compounds. Remember, you have your cation and your anion. Change the ending of that anion to "ide." For instance, sodium bromide, things like that. All right. Acids are going to be named primarily on their anion, so the negative part of that ionic compound. So, because you all already know how to name ionic compounds, which we learned in Unit 3, and we've been doing every unit since Unit 3, today we're going to discuss how to name acids. So, first, we're taking a look at just the most simple form, binary acids. So we know the prefix bi, right here where it says binary, bi means two. So binary acids have two different atoms. Some examples of those will be HCl, HF, and HS2. So as you can see, they are made up of two separate atoms, hydrogen and chlorine, hydrogen and fluorine, hydrogen and sulfur. No more, no less, it is made up of two different atoms. So in order to name these binary acids, you would give them the prefix hydro, and then the first syllable of the anion and the suffix -ic. All right, so let's take a look at what does that mean for these three examples that we have written here. So for HCl, then we know that's a binary acid, so I'm going to say hydro, all right? And then that is chlorine, so chlor is the first syllable of the anion, and then add the ending -ic, hydrochloric acid, all right? Hydro is my prefix, -ic is my ending, and here's that anion. Remember, we said it's named off of its anion. All right, and then looking at the second example here, you have HF. There's two different elements here, letting me know that it's a binary acid. So then we're going to start with our prefix hydro, and then the first syllable of our anion, which is your fluorine. So you've got fluor, and then ending in your suffix -ic, all right? Hydrofluoric acid. All right, so there again is your prefix, your first syllable, and your suffix. So, taking a look at naming complex acids, taking it a little step further. Complex acids are going to have polyatomic ions in them. All right, for instance, down here we have H and then NO3. So remember, you have your list of polyatomic ions on the back of your periodic table. If you don't have that, you should easily be able to find one in Google Images. That's where I found this at. That talks about all your different polyatomic ions. Remember, poly means more than one, so polyatomic, more than one atom, making up that polyatomic ion. So for any of those ions that end in the suffix -ate, we are going to replace that with -ic and then add the word acid. So if you look down here at the example, we have hydrogen and nitrate. All right, so nitrate, we're going to take that ending -ate and change it to -ic. So then you get nitric and then add the word acid, nitric acid. And then your other ending for your polyatomics is -ite. So polyatomic ions that end in -ite, we are then going to replace that ending with -us and add the word acid. So down here, our example, we have hydrogen, nitrite. All right, so we're going to take that -ite ending on nitrite and we're going to change it to -us and add the word acid to get nitrous acid. All right, please make sure you're not overthinking this as you work through it. So if we're looking at this polyatomic list, for instance, here's a bunch of ites. Your ite words, hypochlorite, chlorite, hypobromite, bromite, etc., those that end in ite, the ending would be changed to -us and then followed by the word acid. For those words, those polyatomics that are ending in -ate, for instance, if you look at the left column again, chlorate, perchlorate, bromate, perbromate, acetate, things like that, those will then that -ate will be replaced with an -ic, and followed by the word acid. All right, so now that you're able to determine the names of different acids, we're going to go back from name and take it back to the formula. So those names that you wrote that started with hydro, that's what lets you know that it was a binary compound or a binary acid. So that tells you that there's only two different elements involved. For instance, we have hydrofluoric acid down here at the bottom. That hydro lets me know that it's a binary acid. In order to have an acid, you have to have hydrogen. So there's only one other element present. Well, fluoric, if we look at it, take the ending ic off, what does that look like? It looks like fluorine. So you have HF, which is your hydrofluoric acid. Then when we get into all of our others, we're going to use those suffixes to determine the polyatomics. So everything other than the binary acids had polyatomics present in their formula. So if your name ends in ic, then that means that your original polyatomic ended in 8. So you're going to change that ic back to 8, and that's going to let you know what that anion formula of the polyatomic was. If your acid name ends in us, that lets you know that your original polyatomic name ended with ite. So then you can change us back to ite, and that will let you know what the original anion was, what your original polyatomic was, so that you can then determine the formula. All right, remember, all of these still start with hydrogen because they are acids. We're going to look at some examples of those here in a minute. All right, so as you know, there's always some exceptions in chemistry. These are all going to follow the same naming rules. However, there's just a few little tweaks to it. So as we know, CN, that is cyanide. Cyanide. It is a polyatomic that ends in "ide" instead of 8 or "ite." So that's the only difference. And this one that makes it a rule breaker is you're changing that "ide" to "ic" instead of 8 or "ite. But again, still changing it to the same ending. Then when we look at sulfur and phosphorus, those two are going to act the same. Again, they are following the same rules. However, you're keeping a little bit more of that root word than you are on the rest of your elements. So if we look at H2S or hydrogen sulfate, hydrogen sulfide, if we look at those and we're naming them in the acid form, you're going to actually keep the UR that's in the sulfur. Instead of cutting it off after the first syllable, sulf, you're going to keep the UR before you add your ending. So remember, you're still going to use your ic endings, your ic suffixes for your polyatomics ending in 8, and your us suffixes for your polyatomics ending in ite. However, you're just keeping more of that root word. And then same exact thing for phosphorus. You're still following the same ic and us rules. However, the only difference is you're keeping a little bit more of that root word there. So you're actually keeping the OR. So instead of phosphic or phosphorus acid, it would be phosphoric acid or phosphorus acid. All right, so now looking at some practice examples of what we've been talking about so far today. When I look at this first example here, carbonic acid, I don't see the prefix hydro, so that I know this means that it involves a polyatomic ion. Because it ends in ic, I know that my original polyatomic was called carbonate. All right, so I have a H in front since it's an acid, and then carbonate is CO3. Because carbonate has a -2 charge up here, then swap and drop those charges, and you have H2CO3. All right, taking a look at example 2 here. Hypochlorous acid. I don't see hydro, so I know that this has a polyatomic in it. And this us lets me know that my original polyatomic was called hypochlorite. All right, that is going to be your ClO. So, and then I have a hydrogen because my ClO has a charge of -1. Then when I swap and drop, my charges cancel out. And my formula for this acid is ClO3. All right, your chlorite comes from right here. That is your ClO. Same thing up here. Your carbonate is right here at your CO3. And because they are acids, they are all starting in the hydrogen. All right, so acid is why you get your hydrogen. All right, so now let's take a look at nitric acid. That ic lets me know that my original polyatomic ended in 8, which would be nitrate. All right, so nitrate's formula would be NO3. Because it's an acid, I know that I have an H in the front like we just talked about. And NO3 is a -1, so your charges are going to cancel out, and you're left with HNO3 for nitric acid. Moving on to the next example, that's going formula to name again. So I see only 2 different elements, H and Br. That lets me know that this is a binary acid. So I have hydro, and then the first syllable, so brome, and then the suffix ic, acid. All right, hydro, and then the first syllable, brome, and then ic, hydrobromic acid. So those are your binary acids. So then at the bottom, looking at going back the other way, I have hydroiodic acid. That hydro lets me know that this is binary again. So then I would have H, and then I only have one other element because this is binary. Bi means 2. So hydroiodic, iodic is referring to iodine. So I have HI as my formula.